that if the same reaction is happening at 5 mol per dm3, what will happen now? It means that this is now what is going to happen to the reaction and to the product, right? So it means that the product will happen at a faster rate. Can you see that it reached the what? The terminal so much faster than, and then it means that also our reactions are going to faster as well. Can you see? This compared to that, it means that this reaction happened faster than this, because this one reached the end at a smaller time than this one.
Yes.
Does it make sense? Does it make sense? Now let's talk about surface area, right? Let's talk about surface area. So we talked about temperature, we talked about concentration, and now let's talk about surface area. Yes.
Au maprotein ya hapa.
Yeah?
Kama ya hapa maprotein gani?
No. I didn't hear anything from that.
No.
Okay, surface area. What are you talking about on surface area, guys? What do you talk about on surface area?
Big.
How big or how crushed something is, right?
Yeah.
So again, let me give another example, right?
This one, let me give you an example.
We are having
Are you teaching?
what do you call that type of salt? That's Majoro salt. It's called what?
Stone salt.
Salt, right?
And the matumbo salt.
It's called salt, right?
Matumbo.
So if you're having that kind of salt, right, and you put it in water, and we have that fine salt, and also put it in water, right, which one will dissolve faster?
Fine.
The fine salt. Don't forget that that dissolving of the salt is the reaction taking place. So the reaction is taking place, right? So which one is happening at a faster rate? Which one is happening at a faster rate? Fine salt, right? Why do you think that? Not because it dissolves fast. Because we've increased the what? The surface area.
How?
Right? If we take this one, can you see this? And you place it here. Can you see the amount of area that it covered? It's only this small, right? But if you take this and you crush it and you place it here, it will cover a bigger space, right? So it means that this one is having what? More surface area than this one that is not crushed.
Solid.
Right?
Solid.
That is solid, right? So what does it mean? It means that solids, they have slower reaction rate than what? Than crushed objects. Does it make sense?
No, it is more than gas.
No, we're not talking about gas here. Okay, let me repeat this what I said, right?
Yeah.
Let me talk in terms of salt, right?
In terms of
That salt, that costs like this, right? If you place it in water, it means that it's only going to occupy that space that it is on, right? Right? But if I crush it, it means that it will cover the whole surface of the water bottle, right? So if it covers the whole surface, it means that the reaction is happening at a faster rate than when it is just occupying a smaller surface area. Why? Because the particles have more surface to hit on than when it is what? Right?
When it is crushed,
Yes.
currently not crushed, move up freely.
Not really moving free. It's not really about moving free. It's more about those particles, those small particles, they will have more points to hit on than when it is solid. Can you see, if I'm holding my fist like this, can you see like this, right? So it means that if this is reacting with something, right? So it means that it will just react on this side, can you see? And then that's it, right? But if this is crushed, right? This is crushed, right? It means that the particles can react with this side, this side, this side, this side, this side, this side. So there are many sides to hit on than when it is. Does it make sense? Does it make sense? So what can you conclude with this? We can say that increasing surface area increases the reaction rate, right? So increasing the what? The surface area increases the what? The reaction rate. Yes.
I don't know if the more the substance covers the surface
The bigger surface area.
the bigger surface area.
The bigger the reaction.
Yeah.
Yes. It is also the same thing.
B3.
This one is so
I
complicated.
5%. 5%.
Collision. What about collision? They will collide frequently.
Yes. So in terms of collision theorem, this is what you are going to say, right?
Or not?
According to collision theory, this is what you are going to say, right? Crushed or powdered particles have more surface area to be heat on, right? So if there are more surface area to be heat on, it means that whenever they are going and heating everything, it means that collisions are happening, right? So if they are having more surface area to heat on, it means that more of these particles are likely
Or powder.
to heat on each other, right? Right? And we said, how does the reaction happen? When things collide. And when they collide, what happens? Reaction happens at a faster rate, right? So it means that when they are hitting on each other, what happens?
The reaction.
Reactions will likely to happen at a faster rate. Right? So the more they are hitting on each other, the more likely they are to what? To react. Right? So increasing the surface area means we're increasing the what? The reaction rate.
What about?
Because if we're increasing the surface area, we are increasing the what? The surface of particles to be heated on. And when when particles hit on each other, reactions, they're what? They're happening.
In concentration.
So in concentration, it was about what? It was about more particles at a given space. You get it? So this is not about more, but it's now about the surface area is now bigger than before. Does it make sense? Does it make sense? Yes. Comrade? Okay. Between concentration and this. So concentration, I took it as this, right? If I took that oros, you see that oros, there's water here, and I say, nyam. What happens? So it means that this is not sweet, right? So it means that there's just less particles in here of what? Of oros, right? But if I think, there will be what? More particles of oros, right? And if there are more particles of oros, what is happening? It turns sweeter, right? So it means that even if I pour like that oros down here, it means that there are more particles of what? Of oros, and they can react with anything at a faster rate. But at that point when I said tuanyan, if I do like this, will there be oros particles? No. So I'm just talking about what? The amount of particles that are there, right? Increasing the concentration increases the number of particles that are there. Does it make sense? Yes. But about surface area now, we're talking about something that is having the same amount of mass. If I take this, right, the mass of this will never change, right? It will remain the same, right? And I place it in maybe it is reacting with something, and I place it there, right, like this. It means that the walls of colliding with this, they are so slim, right? The walls of colliding with this, they are so slim. But if I crush this and I place it here, so it means that the walls of this to be collided on, they are more now, right? So if there are more surface area, it means that the collision is likely to happen faster.
Yes.
Just like we said, in coarse salt, the reaction happens slower, right? But in fine salt, just 2 minutes, the salt is gone. Right? Does it make sense? Okay. So let's move to pressure. What is pressure?
Pressure. It's only 10.
Pressure.
It's only 10 in my community.
So let's talk about pressure. And one thing that I forgot to tell you, so temperature, right? Temperature can affect all the states of the reactants, right? When I'm talking about the state of reactants, what am I talking about? It's either is it solid, is it liquid, or is it what? Gas. Increasing the temperature affects everything, right? And concentration affects the what?
Liquid.
So concentration affects liquids, right? And also gases, if I'm not mistaken.
It's
And gases. The concentration of gas can increase, right? So what about surface area? Surface area only affects the what? The solid, right? It doesn't affect gas or liquid, right? The surface area. So this affects the what? The solid. And then pressure affects the what?
gas.
The gases, right? So
But-
pressure is strictly about what? Gases.
Concentration.
You are making noise. So I said concentration affects liquids and gases, right? But surface area affects the what? The solids. And pressure affects the what? The gases.
Temperature affects liquids.
Temperature affects everything. Solid, liquids and gases, right? Right? So let's talk about pressure. What can you say about pressure? What can you say about pressure? I said it affects the what? The gases, right? How do we mean by the gases? So just imagine, what is pressure? What is pressure? So if we take a ball, right? A ball, right? And you pump it with air. What does it mean about the ball? Does it have more pressure or less pressure?
More.
There's more pressure. But now, what really happens with pressure? Pressure is actually how much gas is exerting at the wall of a what? Of a container. Right? How much? Is there anyone that is having a plastic? A plastic. Do you have it? Can I please have it? Plastic. Yes, a plastic. Any type of plastic.
Tari suruh mencabut plastik
Give me a
raya
check out.
sih. Tari semua macam bisa plastik raya sih.
Okay, so let's get it on, right? So I said, gas now, ne? If we take a gas, guys, no. If we take a certain amount of gas, right? A certain amount of gas, and you put it in that container that way, where is it?
That one.
Where is it? Someone Okay. So if we take a certain amount of gas, right, and you put it in this, right, so it means that those particles of that gas, they are colliding with this container, right? Right? But now, if I take a smaller container, right, and I put the same amount of gas, where between this and this that have more pressure?
The smaller one.
The smaller one, right? Why? Because those particles are colliding with the wall more frequently than in this bigger one, right? Does it make sense? Does it make sense? So it means that increasing the pressure. Have you ever took like an inflated ball, a ball without pressure, ne? A ball without pressure, right? When you are holding it like this, you are not increasing pressure, right? But when you compress it like this, you are making the surface, the container to be small, right? And there will be so much pressure inside. Why? Because those gases that are inside, they are fighting with the what? With the wall of the, right? So increasing the pressure, it's self-explanatory again. Increasing the pressure, it means that I'm increasing what?
The rate of what?
The rate of reaction. How? Because if I increase the pressure, it means that the gas particles inside, they are fighting with the wall more frequently than in the bigger container. Does it make sense?
Yeah.
So increasing the pressure increases the what? The reaction rate. Because now particles are colliding more frequently because it is at a what? Smaller space than at a what? Bigger space. Right? It's more like if we take you alone, right? And you put you in this class and say you must run around. It will take time for you to hit the walls, right? But if we take you and then we put you in a smaller room, right? You hit the wall more frequently, right? Does it make sense?
Never eat the room house.
Does it make sense? So what does it mean? It means that increasing pressure also increases the what? The rate of reaction, right? How? If we increase pressure, right?
Yes.
The particles are more likely to hit on each other, right? And when particles hit on each other, what happens? Increasing pressure increases the rate of reaction. Yeah? So it means that the reaction happens faster. And when the particles are more likely to hit on each other, right? Because there is a small space. And when that happens, reaction happens faster. Does it make?
Yes.
Is it giving?
Making sense.
Is it giving?
Yeah.
Is it giving?
It's giving. It's giving.
It's giving.
It's giving. It's giving.
It's just to give.
The God knows what.
It's make sure.
Just to give.
Right? So that is about the pressure, right? So now let's go to catalyst. So catalyst I was writing. Yes.
The particles are
More likely to hit on each other, and the rate of reaction will also what?
Increase.
Is it understandable? Okay. So now let's talk about catalyst. What is a catalyst?
Speed up chemical reaction.
So what does it do?
It speeds up chemical reaction.
So maybe let me just talk about it, right? Catalyst. What is a catalyst? We say a catalyst is a chemical that speeds up the chemical reaction without itself being used up in the what?
Reaction.
How does it do that? How? It does that by just lowering the activation energy, right? It lowers the activation
Energy.
What is the activation energy? What is the activation energy? The one that kickstarts the what? The reaction, right? So as you know that some of the reactions, if you just let's say
The imo factor
salt
kama
and sugar
Yeah.
at the same time,
Yeah.
you place them
Factor.
together. If it
iko da ka reaction rate.
Yeah.
If you take salt and sugar, right, and you place them at maybe
Okay.
a page of a book, right, what happens to them?
Very
Nothing,
mabuti.
right? Because the energy needed for this to react
I
is
can't.
not met, right? But if you take them and you bend them now, what will happen? They start to mix, right? Why? Because now they're getting the what? Activation energy, right? So each and every reaction, they have their own activation energy, right? Yeah. So the catalyst lowers the activation energy, right? You may find that you are having salt and sugar here and you didn't use it, we just pour a catalyst, a suitable catalyst maybe, and you see them what? Mixing, right? Because we have put a what? A catalyst. So a catalyst just lowers the activation energy. So now here comes the question. If I lower the activation energy, what will happen to the reaction rate? It will increase.
Yeah.
Right?
Directly.
Because if okay, let's get this right. Ne? If perhaps maybe I'm having a reaction ne? That happens at 50 degrees Celsius, right? And right now I'm still burning my things, right?
Yeah.
They are still at 20 degrees Celsius. The temperature still are rising, right? And then I put a catalyst that lowers that activation energy, right? Maybe it lowers it to 27 degrees, right? So what will happen to the reaction? It means that when it gets to 27 degrees, it will happen. It will happen so fast. Then without a what? A catalyst. So it means that with a catalyst, a reaction will happen more faster. Because the activation energy has been lowered. And if the activation energy has been lowered, what will happen? The reaction will happen before it should have happened. So it happens faster. Does it make sense?
Yeah.
So the reaction always activation
All reactions they have their own activation.
is only determined which one.
Yeah. Just depends on which one we are talking about, right? So there's that nature of reactions. We won't talk about it, right?
Nature of what?
Nature of reactions.
Okay.
I just talked about a lot of useless things that they want to
Have you useless things? Is there useless things in this book?
So let's open page 229. Do you have your textbook?
Page what?
229.
I was thinking.
Page 229.
I like page 29.